Hello class. Today me and Sean and JP are teaching you guys how to make a quicksort algorithm. So let's go into the overview. A quicksort algorithm, it pivots around an element that it arbitrarily chooses, and it divides the array based on this element into two subarrays. After this, it reads the element value and swaps the pivot value to a new position, and it repeats the process using smaller and smaller arrays until all elements are sorted. So it recursively goes through the array until it finds the element and sorts it. This uses a divide and conquer algorithm, and it is not a stable algorithm, meaning that small errors in the data can severely mess up the algorithm and how fast and slow it is.
Okay, so this is a little step-by-step instructional guide on how to do the quicksort algorithm and how it works. All right, so in this first picture, we got 3 as the pivot element. We'll say 3 was somewhere in the middle, and the computer selected it. So you're going to want to take your pivot element, and the computer will move it to the right side. And so now the computer will go, it'll create 2 new elements. It'll do the element from left, where it reads each element from the left until it reads an element that's bigger than the pivot. So currently it's 3. So the element from the left would be, it would read 9, and 9 is bigger than 3, so this would be element from left. And then it would also do element from right, which it reads the elements from the right side until it reaches an element that is smaller than the pivot. So currently it would read the first element 1, which is smaller than 3, and it would see element from right is 1, element from left is 9, and it would switch them. So that means 1 would go over here, and 9 would go over here. And now it repeats that process again and again and again until element from left is on the right side of element from right. And in that case, the pivot element is switched with the element from left, which means that 3 will go into its correct spot. And as you can see here, once 3 is in its correct spot, then all the elements to the left of 3 are smaller than 3, and all the elements on the right are larger than 3. And this is a recursive algorithm, so it'll pick a new pivot element for each of these smaller subarrays and repeat that process until each element is locked in to its correct place, and then all the elements are sorted at the end.
So now that we know how it works, we can teach you guys how the code actually works. So right here in our code, we have 2 methods. We have the quicksort method and the partition method. And basically, the very first line in the quicksort method, in pivot index equals partition, it takes an array, a low index and a high index. And what this method does is it basically gets the pivot index that we're looking for. And if we look at the partition method, what it's doing is that it's choosing the last element in the array as a pivot, and it's keeping I as the index of the smaller element. And the for loop, what it does is it checks if the current element is smaller than or equal to the pivot, and if it is, it swaps them. And after this swap, it swaps the pivot and returns the pivot index. And we recursively do the quicksort method twice. And the very first quicksort method is sorting the left array that you guys just witnessed, and the second quicksort method is sorting the right array that we just saw. And so it recursively does this over and over, as you guys saw, and will sort the method, or sort the array.
Okay. The big O notation for the quicksort array is as follows. The worst case is big O of n squared. This is when the pivot is not correctly selected. So typically you want to have your pivot be somewhere towards the middle of the index, where about half of the index is on the left side and about half is on the right side. And then the worst case, that would basically mean your pivot is either on the extreme right or the extreme left. So that way you have one of your subarrays or one side of your array has like a million bunch of different elements, and then the other side has like 2 or 3. And that just makes the algorithm take a really long time. And the average and best case is big O of n log n. And that basically means that the pivot element is about in the middle of the array. So that way both of the subarrays are about equal size to each other, and it speeds up the algorithm a lot.
All right, so now we know how Quicksort works, but what does that do if it doesn't actually have real life implementations? Well, for one, you can organize a grocery list, and it is very efficient at this because Quicksort is the quickest sorting algorithm when your data is organized well. And in a grocery list, it's already easy to do that, so Quicksort will just efficiently sort your list for you. Another thing is sorting cards. This can be a really efficient way if you're trying to make let's say you're trying to make a poker game or a blackjack game. Sorting the cards and organizing them can be very helpful. Thirdly, you can optimize data when data mining. So let's just say you want to get a bit of Bitcoin, you want to get rich. Well, Quicksort can definitely help with that, and it can optimize the data that you're dealing with so that you are more efficient and you're getting more money. And lastly, but not finally, you can do much more with Quicksort, but these are just the examples we're showcasing. You can sort e-commerce by price or rating. So this is useful for, let's say you work at Amazon and you're a software engineer trying to get a user, you're trying to list the items by price, high or low. Well, Quicksort would be a really good way to do that because it's just quick and it deals with data very efficiently when it's sorted in a way that it can work well with it. So next we're gonna show you guys how to walk through a walkthrough of our activity that we made. I'll pull up just a warning, this will show you guys the answers, so don't watch if you guys haven't done it already, but I will pull it up really quick. And so as you guys know, you are dealing with the Quicksort method and you are trying to debug it. So as you can see, bug 1 is that the less than or greater than sign should only be a less than sign. Bug 2 involves the pivot index not subtracting 1, so this will cause a array out of bounds index. Our third bug is that this should be high and not low because we want to set our pivot to the high index, so that would be the very last index in our array. Our fourth bug is that low should start at low minus 1. For our loop should be j is less than high, not j is equal to high, because that will once again cause the loop to loop more elements in the array. So we have to do less than and not less than or greater than. And then this piece of code right here should be less than or equals to pivot and not just less than.
All right. We got some more bugs here. For this part, we should swap the array I and the pivot array low. These are the wrong indexes for this part. Should swap array I plus 1 and array high instead of the other way around. And then this should return I plus 1 instead of just straight up I. Down here, we got the swapping logic is reversed, so these need to be fixed. Top of the main method is good. This right here should be array.length minus 1 instead of just regular array length. And I think that is the last bug on here. So yeah, if you got all those bugs, then well done.
Yep, good job guys if you got those without having to follow this part. But to conclude, sorry about this guys. To conclude, we want to thank you guys for watching, And we hope you guys have a great day. Stay warm out there, and we hope you guys learned something new.
Quicksort algorithm. Use it. Yeah.
Yep.